Solar radiation, extraterrestrial. The solar radiation that would be received in the absence of atmosphere is generally termed as extraterrestrial radiation. So, extraterrestrial solar radiation has a spectral distribution having a wavelength of zero point 0.1 to 2.5 micrometers. So, it includes ultraviolet, visible, and infrared. So, coming to the solar constant. So, solar constant is nothing but it is a value where the amount of solar radiation that will reach the outer atmosphere when Earth is at its mean distance from the Sun. So the solar constant is generally 1367 watt per meter square. That is the value of solar constant. So coming to the variation of extraterrestrial solar radiation. The maximum value of solar radiation or solar constant value is 1367 watt per meter square. So coming to the value of solar radiation, that is equal to solar constant into 1 plus 0.33 cos of 360 into n by 365, where ixt is the extraterrestrial radiation, that is the solar radiation that is falling on the outer atmosphere. IAC is the solar constant, that is 1367 watt per meter square, where n is the days of the year. Suppose if it is a January 1st, the n value is 1. If it is a February 1st, the n value is January is 31 days and February is 132. N is equal to 32. So the maximum value of n is 365. That is a formula for calculating the solar radiation at a particular day. So coming to the energy distribution, so whatever the solar radiation that is coming from the sun, so 30% of the solar radiation will be reflected by the surface and only 51% absorbed by the earth and remaining 19% reflected through the space or reflected by the clouds through atmosphere. So only 51% is absorbed by the earth, 19% is in atmosphere, and remaining 30% is reflected by the surface. This is the total energy distribution or total solar amount radiation that will be distributed in the earth atmosphere and reflected back by the air. So solar radiation on earth surface. So generally the solar radiation or may be called as global radiation or direct radiation is nothing but the direct radiation, diffuse radiation, and reflected radiation. Why? Because so whatever the solar radiation, some is absorbed that is directly falling on the earth, some may be reflected, and some may be absorbed by the or scattered by the air. So total radiation is the sum of direct radiation, diffuse radiation, and reflected radiation. That is the formula for total radiation or global radiation. Air mass. So generally, the term air mass is used as a measure of the distance traveled by the beam radiation or total radiation, direct radiation through atmosphere before it reaches a location on the earth surface. That is termed as air mass. So it is generally in terms of formula, it is defined as a ratio of the mass of the atmospheric through which beam radiation passes to the mass it would pass through the if the sun is directly overhead. That is nothing but the zenith angle. Okay. Zenith angle is the angle made by sun's rays with the normal to the horizontal surface, where air mass is given by 1 by cos theta or it may be secant theta. So measurement of solar radiation. What are the measuring instruments that are used for measuring the solar radiation? So we have the different solar instrument measurement equipments, that is pyranometer, pyrheliometer, and sun recorder. So a pyranometer is designed to measure global radiation. It is usually on a horizontal surface but can also be used on an inclined surface. Pyrheliometer, an instrument that measures beam radiation by using a long narrow tube to collect only beam radiation from the sun at normal incidence. So sunshine recorder, we have to record. So it measures the sunshine hours in a day. These are the various solar radiation measuring instruments, that is pyranometer, pyrheliometer, and sunshine recorders. So these are the basic definitions that we are using in solar energy: radiation, irradiance, insolation, declination, terrestrial radiation, albedo, zenith angle, equinoxes, solstices, alpha and perihelion. Okay, these are the basic definitions that we are using in solar energy. So coming to the solar radiation geometry. So this is a latitude or angle of latitude. So angle of latitude is nothing but it is the angle made by a radial line joining to give location to the center of the earth, which is projection on the equator plane. So it is from center of the earth to the projection on the equator plane. So this is a angular displacement, which is given by 23.45 into sine of 360 by 365 into 284 plus n, where n is the nth day of the year. So this is our angle that is calculated by using this formula. So generally the hour angle, or it may be measured by in terms of degrees, is nothing but solar time minus 12 into 15. This is the formula for calculating the hour angle, or hour angle at any moment. So inclination angle, the angle between sun rays and its projection on a horizontal surface, that is given by horizontal inclination angle. Next one is zenith angle. So it is generally perpendicular to the horizontal plane. The angle between the sun rays and the perpendicular to the horizontal plane, that gives the zenith angle. So this is the solar azimuth angle. This is a formula for calculating the solar azimuth angle. Surface azimuth angle, and this is the tilt angle. Okay, so the angle between the inclined plane surface and the horizontal plane, how much the solar characters are tilted with respect to the horizontal, that gives the solar tilt angle. So angle of incidence, that is the sun rays incident on the plane surface and the normal to the surface. So these are the various formulas that we are using. Next we have to calculate the solar day length by using this formula. So 2 by 15 into cos inverse of minus tan phi into tan delta. Now coming to the solar thermal collector. A collector is nothing but which collects. Solar collector means the collectors which collects the or absorbs the solar radiation. It collects the heat by absorbing sunlight. A collector is a device for capturing solar radiation. So basically, we have the two types of solar collectors. One is non-concentrating collectors and concentrating collectors. The example for non-concentrating collector is flat plate collector. Flat plate collector is the example for non-concentrating collector. Coming to the concentrating collectors, so generally the collectors are in the shape of parabolic. So parabolic collectors, the shape of the collector is just like the parabola. Then it may be a concentrating collectors. Generally non-concentrating collectors are used for low heat Generally, this is used for heating purpose, that is solar heaters, whereas concentrating collectors are used for high heat. So classification of collectors. So flat plate collector is example for non-concentrating type collector. Why? Because the total solar radiation will fall on the entire collector, not concentrated only at one place. Total entire place, the solar radiation will fall on the entire space. That's why it is called as non-concentrating collectors. The example for non-concentrating collectors are flat plate collectors. The observing surface is approximately as large as the overall collector area that intercepts the sun rays. So here, observing surface is or nearly equal to the collector area, whereas concentrating collector, large areas of mirrors or lenses focus the sunlight onto a smaller observer. Means the total falling area and total collector area will be very less. That's why they are called as concentrating collectors. So flat plate collectors. So types of collectors based on low temperature, generally flat plate collectors, medium temperature, parabolic through and fractional collectors, high temperature, almost 4, above 400 degrees centigrades. So central tower type solar collectors are parabolic dish type collectors. So these are the various collectors that we are using for various temperatures. That is for low temperatures, normally less than 100 degrees, medium temperature, 100 degrees to 400 degrees centigrades, and high temperature above 400 degrees centigrades. So non-concentrating type collector is only flat plate collector. So parabolic through Fresnel collector, central tower and parabolic dish all are comes under the concentrating collectors. So this is the diagram of flat plate collector where it contains the observer plate, insulation, flow tubes and header. So a typical flat plate collector is a metal box with a glass or plastic cover on top and a dark colored observer plate on the bottom. The sides and bottom of the collector are usually insulated to minimize heat losses. Whatever the solar radiation that is falling on the surface of the flat plate collector, that will be absorbed by the plates. Okay. Generally, the flat plate collectors are most used for solar water heating. Why? Because they are used for low temperatures, normally less than 100 degrees centigrade. So flat plate collectors heat the circulating fluid to a temperature considerably less than that of the boiling point of water and are best suited to appliances where the demand temperature is less than 100 degrees centigrade. So generally these collectors are typically used for heating buildings and drying crops. So flat plate collectors can be mounted in a variety of ways depending on the type of building and size of collectors. Options include mounting on a roof or in the roof itself or freestanding. So flat plate collectors can be mounted anywhere on the roof or room itself or freestanding. Next one is evacuated tube solar collectors. So evacuated tube solar collectors converts energy from the sun into useful or usable heat in a solar water heating system. So this energy can be used for domestic and commercial hot water heating, pool heating and space heating. So it mainly contains evacuated tube where it absorbs the solar energy and converts into usable heat. Heat pipe, so generally copper vacuum pipe that transfers the heat from the within the evacuated tube. Manifold, that is insulated box containing the copper headed pipe and mounting frame, strong and easy to install with a range of attachment options. So these are the various. This is the diagram of evacuated tube solar collector, where it contains the headed pipe, manifold, evacuated tube, heat transfer fin, and heat pipe. So concentrating collectors. So the examples of concentrating collectors are parabolic through, central tower, distilling, and Fresnel collectors. So whatever the solar radiation that is falling, that will be concentrated on the mirror and reflected back to the surface of the towers. So parabolic through collectors. So this is the diagram of parabolic through collector. So whatever the solar radiation that will be falling, that will be collected by the collector and it will be reflected to the fluid point. So here at the center we have the fluid, where we have the fluid in and fluid out. Whatever the solar radiation that is falling on the parabolic type device, that parabolic shaped reflective, that will be reflected towards the central heat pipe. So whatever the heat energy that is absorbed by the heat pipe, so whatever the fluid inside the pipe, that will be absorbed by the heat energy and converts into heat energy. So it contains mainly parabolic shaped reflective through and reflective coating of mirrors, and it is having the central heat pipe and collector supporters. So whatever the fluid that is inside the heat pipe, the solar energy will be absorbed by the heat pipe or fluid inside the heat pipe and get heated. So this is a parabolic collector power plant where it converts the heat energy into mechanical energy, and that is converts the mechanical energy into electrical energy through generator. So concentrating type collectors. So these are the parabolic through central tower, distilling and Fresnel collectors. So these are the examples for various concentrating type collectors. Now the advantage of or application of solar collectors. So mainly we are using for solar heating and solar cooling, heating and cooling purpose. So a passive solar heating system is a way for the building materials to collect, store, and distribute solar energy by nature convection, conduction, and radiation. So homes with high potential for solar electricity usually have good potential for passive solar heat. So the diagram of solar heating system contains mainly five parts. One is the aperture, absorber, thermal mass, distribution, and control. So what are the three passive solar heating? One is the direct gain, indirect gain, and isolated gain. So solar passive cooling. So cooling systems are least expensive means of cooling a home, which maximize the efficiency of the building envelope without any use of mechanical devices. So what are the methods of passive cooling? Natural ventilation, shading, wind towers, earth air tunnels, evaporative cooling, and passive down draft cooling. So these are the various methods of cooling system. Now how we are using the solar energy for generation of electric power or mechanical power. So mainly it contains solar collectors, and we have the storage tank which stores the water, and we have the heat exchanger. From heat exchanger we have the expander, or it may be a turbine, steam turbine, and then from steam turbine it is to the mechanical power. So whatever the heat that is generated inside the solar collector that will be absorbed by the fluid in the storage tank. Generally, the fluid may be water. So the water absorbs the heat energy, and that heated water or heated fluid will be sent to the heat exchanger, where it again raises the temperature of the fluid. That water or fluid convert into the steam, that giving to the steam turbine, so that the steam turbine starts rotating, so that it generates the mechanical power. So whatever the exhaust steam or unused steam, that we have to again utilize. So that exhaust steam or unutilized steam will be sent to the condenser, where the temperature of the steam will be cut down by adding the cooling water, so that the exhaust steam will be converted into water, that water again pumping to the heat exchanger. So it is a recycling. Whatever the unused steam or exhaust steam, again we are recycling to get the convert the steam into water. So this is the application of solar collectors to get the mechanical power from mechanical to the electrical power. This is a function of the solar collectors. Next one is solar cookers. So basically we have the box cooker, panel cooker, solar funnel cooker and parabolic cooker. So box cooker, which is the easiest and most popular to build and use. Okay. So advantages of slow even cooking for large quantities of food. So this is a panel cooker. So can be built quickly and at low cost. Many different varieties. Solar funnel cooker. So it is safe, inexpensive and easy to use. Combines best of parabolic and box cookers. Anyone can make them. Next, finally, parabolic cook. So highly focused light and high temperatures. So the cooker shape is just like the parabolic. Cooks nearly as fast as conventional oven. It is costly and complicated to make and use. Have to turn frequently to follow the sun. Why? Because it is in the shape of parabolic. So the sun rays will starting from east and ends at the west. So we have to turn down frequently in the direction of falling the sun. That is the main disadvantage of using parabolic cooker. Potential hazard outs not recommended. Okay. This is about the various cookers that we are using by use of solar cookers. One is a box cooker, panel cooker, solar funnel cooker, and finally parabolic cooker. So among these cookers, so box cooker is easiest and parabolic cooker is very complicated, not recommended. This is about the applications of solar collectors for heating, cooling, and also for used for as a cooker.